practice?
Just wait, ma'am, wait, ma'am.
Okay.
Good evening, all of you. The next speaker is Vijeta Bachan, ma'am. She did BTech from Kalinga Kit University and she completed her master degree MTech from NIT Patna in water resource engineering. And currently she is pursuing PhD. It's about to finish. She is working in GEC Buxar, but currently deputed in Bihar Remote Sensing Application Center, Patna. She worked as assistant engineer in urban development and housing department for 2 years and headed Amrit Yojana. She worked assistant engineer in public health engineering department, Government of Bihar, and she has published many papers. She has published many papers. Few are related to IIWA, to water quality and salinity appraisal in Polygon distributory. Apart from this paper, she has published book chapter. She is a very good academician. So today present, her topic is exploring remote sensing, current uses and future potential. So over to ma'am. Ma'am, please.
Thank you, sir, for giving me this opportunity to explain about the topic about remote sensing and how it is beneficial for current as well as for potential. I think everyone must have heard this. It's a very, very vast and wide topic, and it cannot be covered in 1 hour lecture. But I have tried to put some of the useful slides over remote sensing so that I can give some basic ideas about remote sensing to you all. Now, as the word remote sensing, what do you mean by remote sensing? The word itself suggests remote and sensing. Means remote is some outer area we have to cover based on certain instrument or some sensors or some type of accessories which we will use without being in physical interaction with that object. For example, camera. For example, now this is the live example that now I am not able to connect to you all by audio. So sir has given this facility to connect by speaker. So through this instrument, I was able to connect. If this instrument was not possible, if this instrument was not there, then I was not able to connect. So since this instrument is making our life so much easier, in the same way, in our today field, which is a very techno field where everyone is using and talking about technology, remote sensing has emerged the very, very useful thing for all of us. First of all, I am just reading the slide, what is written here, that it involves gathering data about any object without any direct physical interaction. These techniques can analyze and monitor objects or areas from certain distance. It generally captures radiation in various wavelengths. Data which is recorded are generally used to generate images. This is having a wide range in various fields like weather, environment, resource management. It is also enables acquisition and interpretation of geospatial information, and it extracts information about surface features and objects. In a brief word, if we say about this slide, that it is useful in each and every field. For example, since I have worked in field for almost 4 to 5 years, I am knowing a little bit about what are the challenges which have been faced in the field. For example, I was there in UDSD or in Public Health Department, which generally deals with water pipeline. Like nowadays, we are working on some yojana, which is a project proposal, which will be submitted to PhD department. They are having 54,000 yojanas, schemes, on which each and every scheme is having a map. So they are having such a complex data, and they are having very much difficulty in planning or in analyzing that data. So they are giving us that map. They are giving us that map, that raw map, and we have to digitize that map and give it to them. So in that process, they have, while gathering information, they will take 3 to 4 years while analyzing those maps. And we will be able to give it within 6 to months or 1 year. So that is resource management or time management, we can say. So these type of things can be connected to remote sensing. We will see further what are the things which we generally do in remote sensing. What are the tools which we are using? How we are doing remote sensing? So these all things we will see in our later slides. Now, each and every one of us know that technology is having very, very usefulness for us, for our daily life. But on the same way, it is having various disadvantages because each thing has both advantage and disadvantage. In the same way, this technology also holds some advantages as well as disadvantages. First, we will talk about the advantages of remote sensing. It provides a regional view covering large areas. It offers repeated observations of the same location, detects broader spectrum than human eye, focuses on specific or multiple bandwidths simultaneously, delivers geo-referenced digital data, operates in all seasons, at night and in bad weather. So the brief of it, we can say that it is generally covering very large, immense areas. Even the remote areas we can cover through remote sensing. Now drone technology is very, very emerging thing. So those things are generally getting very useful nowadays because it is able to cover even the remotest of the areas. Then the same thing we are getting various nowadays. For example, we are working on sugarcane. Our BSAC team, Remote Sensing Center team, is working on any sugarcane identification. So they were trying, because in Bihar, since we are from Bihar, so in Bihar, very illegal sugar things is happening. They are illegal manufacturing of sugar is there. So they are trying to identify the areas because Bihar is very much sugarcane productive state. So they are again trying to recalculate that thing, the potential, and they are trying to identify the area that is having a large scale of sugarcane. So even in the remote areas, we are getting information that okay, that particular area is having sugarcane production. So how? Through satellite images. We will discuss how the processing is done, but through satellite images, we are getting information that okay, in the remote fields also, that area where very less production is there, that also can be identified on the map. So this is the the greatest example which we are seeing how remote sensing is helping in crop identification and how it is helping to our government. In remote sensing, we are giving geo-referenced data. What do you mean by geo-referenced data? Means each and every data, each and every image will hold certain information. They are having attribute tables. Attribute tables means the tables which is having information of that area, that particular area. So when we will click on that image or on that layer, we will see all the information that, okay, in this area, what is the road connectivity, how many industries are there, what is the facility for the people, like hospital is there or not, any drinking water facility is there or not. So each and every, what is the population of that area, how many men population, female population is there, what is the sex ratio. These all can be identified by just clicking on that attributes table. And we will be sitting in the office and we will be seeing all the information, or any upgradation work is needed, that layer will be added. Again, the data will be collected and that layer will be added. And again, the upgradation work will also be seen in that small attribute table. So how it is benefiting our society, this is a very important thing. And secondly, it can be operated in also. Now the disadvantage is that we need, a layman cannot read that image, that data. We need to be either specialized in remote sensing, or we should have a technical knowledge about it. Means we need a skillful people for reading that remote sense. Secondly, the most problem which we are seeing while working on the images is the cloud cover. Generally in this season, in monsoon season, we are having very difficulty of detecting the major crop. For example, if we talk about crop, that identifying the crop is getting very difficult because of the cloud cover. Generally, cloud cover less than 5%, the image is having is found to be good. If the cloud cover is more than 5%, that image we generally don't include in our study. So that is becoming a very great issue. And if we will buy images which is having a very less cloud cover, then that image is very costly. So we will not be able to buy. So this is the major disadvantage, or we can say the drawback of this remote sensing. Now I will read about the disadvantage. Requires validation through on-ground observation, lacks fine spatial detail for certain applications, less effective for monitoring small-scale areas, demands specialized expertise and systems for data interpretation. Now, less effective for monitoring means it can monitor small areas, but we need high resolution image, high pixel image, and that is again very costly, which will not be, which can't be afforded by our government. So this is again the most disadvantage of remote sensing. Now we move to the next slide. Now we are talking about the types of satellite. Two types of satellite is basically here mentioned. That is geostationary satellite and polar orbital satellite. The name only itself suggests that stationary means satellite is being positioned or stationed at some point, and through that point various location points will be taken. And in polar orbiting satellite, orbit will move and images or data will be extracted based on it. So generally in remote sensing nowadays we are using polar orbiting satellite because it is covering large areas and it is generally used for assessing land use, vegetation cover, water condition, vegetation, monitoring air quality, etc. Now I am reading the slide. In geostationary satellite, it is positioned at an altitude near 35,800 kilometers above Earth. This orbit rotates with Earth's movement, maintain a fixed position relative to the surface, continuously observes a specific geographic area, delivers frequent updates, capturing changes within minutes to hours, essential for monitoring weather patterns and detecting severe events such as hurricanes, tornadoes, and floods. Now we come to polar orbiting, operate at relatively low altitude, approximately 700 to 800 kilometers above Earth, travel in orbits passing over both north and south poles. As Earth spins beneath them, these satellites scan new regions with each orbit. Typically revisit the same location on the planet once every 24 hours or less frequently, characterized by low temporal resolution due to their orbital pattern. provide comprehensive worldwide coverage, serve multiple purposes including air quality monitoring, land use assess, evaluating water conditions, and studying vegetation. In polar orbiting satellite, we are getting various accurate images as compared to geostationary satellite, because in polar orbiting, it's generally moving around. So it's covering a larger area. Then in geostationary, the position has been fixed. So it has some limitation. It has some limited areas through which it can study. So this is the basic thing. That is why we are using polar orbiting satellite in remote sensing. Now, what are the steps in remote sensing? I am just reading it and I will elaborate. First is the data collection. Second is after collecting data, we have to process it. So data processing. After processing, now I will elaborate on it. What we do in remote sensing, how we work generally. First, there is a site called Copernicus site, through which we download satellite images. I hope everybody must have heard this site. Copernicus site. Have you all heard about it? Okay. So through Copernicus site, we generally download satellite image, because the map which we get, the raw data which get, can directly not be imported or used in remote sensing. We have to first work on the image before importing that data to our maps or to digitize it. We have to work on it. For example, if we are seeing like Copernicus site, we have to download satellite imagery. In India, we generally download satellite imagery through NRSC Hyderabad, National Remote Sensing Center. Have you heard about it? NRSC Hyderabad? Everyone is listening or?
Yes, ma'am. Yes, ma'am, they are listening.
Okay. So all of you have heard about NRSC Hyderabad, National Remote Sensing Center?
Yes, ma'am.
Okay, so generally the images which we are getting from NRSC Hyderabad, it is free of cost. It is free of cost, and in all 2-3 images in which we are getting this is in the form of list 4. Have you heard about these images, Sentinel-2 and list 4?
Ma'am, they are saying yes in comment section, so they are listening.
Okay. So they might have heard the term list 4 and Sentinel-2 images. Generally, Sentinel-2 images we are getting very easily, because it's a 10-meter resolution image. Now you will heard about the term to say resolution. What do you mean by resolution or pixel? Generally in remote sensing, we are generally seeing that 1 pixel equal to 10 meter into 10 meter on ground. The basic term is there. That is why, because many of the people, as I have heard, is the research scholar, so they might be learning remote sensing nowadays, but they are into the basic stage. So I am just trying to explain that each and every word or each and every term here in remote sensing has its own existence. So you can see that each and every pixel is having very, what it is denoting? It is denoting area on ground. For example, if we are taking 10-meter resolution, it means that it is covering 10 meter into 10 meter on the ground. 100 square meter of area will be covered in that one pixel. So while calculating it, this term resolution or pixel is very important in remote sensing, because we are working on image. So that is why pixel or resolution term is very important. these type of images. Sentinel-2 is for data you will get easily free of cost. Sentinel-2 images is you are getting easily. Supervised classification and unsupervised classification. All of you can hear my voice.
Yes, ma'am.
Yes, ma'am.
So in crop identification, there is two type of process or not improve identification. We have to extract any features, any images, any identification of certain object which is present there. Then there is two type of classification: unsupervised and supervised class. In unsupervised, what we have to do, just there is an instrument, there is some tool which is there in ArcMap or QGIS or ArcGIS Pro, which are generally used to analyze the data of remote sensing. We can just click on the classification tools and we will having that option of unsupervised, and just we will click it and then we will get the corrected image. But in supervised image classification, we have to train the input. How? First, we have to do the atmospheric correction, cloud cover correction. After that, only the image will be in a corrected form. So this is the basic difference between unsupervised and supervised classification. And again, how you will train the sample or any input? By classifying it based on the pixel value. Now, I have already discussed the pixel thing. Each and every feature is having their different pixel value that we generally get in our project, or you can get on the net. Each and every feature, if there is water body, that will have another pixel. If there is certain grassland or some vegetation cover, that will have another pixel. So each and every feature there which is present, that we can get classified on the base of pixel. I hope this much is clear. Now, what are the tools which are generally used in remote sensing, which is generally free of cost? For QGIS. QGIS is very easy tool as well as free of cost. ArcMap is again ArcGIS is again very important as well as very common tool. Generally, we work on QGIS or ArcGIS maps. In that, we are having various tools. Various tools are there. I hope most of you have worked on that ArcMap, since all of you are professors and all of you have, or some of are doing PhD, pursuing PhD. So all of must have seen the screens that we are having large number of tools over there. For example, if we do water quality, if we want to do water quality assessment, we are working on it. Then we generally have to find out, there is one project in which we have to find arsenic contaminated area of certain remote areas, like in Barhara, which is a very remote area in Kojipur, and generally survey has not been done related to water quality in that area. So PhD department, public health department was wanting a survey, and after survey they were wanting the arsenic contaminated thematic maps to be done in our remote ArcMap or QGIS. So we are doing so. In that, we are using that tool of IDW. You might have heard that term, interpolation term is there, through which we can generally draw the spatial distribution maps of any parameters. Since they have asked for red hot areas of arsenic, so we are working on it. But any metals or any parameters you want to work through IDW tool, which we are using for finding out the spatial distribution maps of any parameters. So if remote sensing is having applications in large scale, is having applications in different areas, in different fields. Now again, after remote sensing, it's an AI or machine learning. It's again an improvised version only. Remote sensing. In remote sensing or in ArcMap, what we are doing, we are creating models. We are validating the model. The same way we are having different models like random forest RF, you can say. We are having various different models about the decision tree. These are the models which are generally commonly used in machine learning. In the same way, we are having machine learning in random forest or tree forest in statistical analysis. I must have, you all have heard about SPSS software. Generally, some of the data which we process, We have to check there statistically whether they are correct or not. Sometimes we have to use that also. So we are using software like SPSS software, which is generally telling the predicting the data very clearly that whether it is appropriate or not. So before exporting those data on the ARC map or QGIS, we are first checking the data, because what happens in remote sensing, most of the time we are sitting in the office and we are we are processing the images. Ground truthing is almost 5 to 10%. In generally in remote sensing or in our government agency, it is there that we have to do ground truthing only 5 to 10%. 90% we have to process the data here. So this is a very important point, because in ground truthing or the engineers which used to survey, they are having a large amount, they have to spend a large amount on surveying. So this remote sensing is also saving their cost, because 10% time, for example, if we are going and we are doing ground truthing, or for example, for a particular area, that we are knowing already what can be the feature there, because almost the topography of some particular area is same. So we don't go area by area, or we don't have to go village by village to identify any feature. If any area fish ponds there, then it might be possible that those areas are NDVI value doesn't vary a lot in a particular district. For example, if I talk about Buxar district or RR district or Patna district, it will almost have same NDVI value for a particular image. It doesn't vary a lot. For example, if we take vegetation cover, so vegetation cover, I have already said it has a NDVI value that lies between -1 to 0. So example, if we are we are going 2-3 villages and we are seeing that okay, its NDVI value is like -1, between -1 to 0, it means there is a vegetation cover over there. So we will not go and survey each and every village. By just we will get an idea only by seeing those two villages. We will get the idea and we will be able to identify by sitting on the office that yes, this area is having a wide range of vegetation cover. Same goes with urban area, same go with water bodies, same go with grassland or any, you can say, barren land. So these are the things which we can then maybe some variation in the data. So for that, we have to go ground truthing at least once a month to twice a month. But yes, we doesn't have to spend so much of time just by doing ground truthing. So this is again a source of time management as well as resource management as well as money management. So these are the things which this is the steps. So first what we have to do, okay, I just want to say that, for example, if image cannot be processed in ArcMap, what we have to do, either it should be Excel or either it should be in camel file. If it is in the form of any raw image or any raw diagram, then first we have to convert it either in form or in KML form. Then only it can be imported to our ArcMap for geo-referencing. We cannot just put that raw map into the ArcMap. So in that we will not be able to process it. That image has to be converted either into the point data or polygon data or line data. then only that data can be imported to our map. So what we have to do in that, first of all, we have to create a layer of it. For example, how to differentiate it? For example, if in a map we have to show road network also, we have to show water bodies in that area also, or we have to show the hospitals in that area also, then how we will identify in that particular area? So there will be a lot of confusion. So what we have to do, we have to generate certain layers of each and what do you mean by layer in it? Layer is just a form of identification of each and every feature that will be given to our art map. For example, if we have to create road net, what we will do? We will take the data in Excel form of road network. What will be the details? Type of road, whether it's NH, national highway, state highway, village road. What is the length of the road? What is its locating? What is its starting point? What will be its destination point? What will be there will be if certain marks are there. For example, there is certain marks like on road we see generally traffic signals are there or certain warnings are written there. So all those signs will be mentioned there. So what all informations you will give, we will collect it and convert it into either Excel sheet, and then we will add that Excel sheet to our art map. After creating that layer, that Excel sheet over that, what we will do, we will just import the map over our art map. By importing the map, when we will right click on it, we will see the attribute table. And in attribute table, it will be seen that whatever information you have given in raw data or in raster form, that has been mentioned in that tabular form. So whatever area, for example, if there are 40 districts or for example 40 villages in a particular area, then if we want to take one village, for example, for survey, we will just click on that village and that village will be selected on the art map. And again, if we want that information, by clicking on that image, we will be able to see the attribute table. We will be able to see the information, each and every information, what is the population, what type of road is there, what is the length of the road. On the same, if we want to, after road connectivity, we want that what are the facilities for people like hospital. What is the hospital connection? So we will again get the data regarding hospitals, like how many hospitals are there, how many doctors are there, how many nurses are there, what is the area which is covered by that particular hospital. So all those informations again separate layer will be formed and then that layer will be imported to the map. If you want to see hospital, then just tick off the road network layer. And then if you want both the layers, then tick on. You just have to tick on both the layers and you will see both the layers. If you want to see only one layer, either hospital or road network, then you can tick out that one layer and again the specific layer will be visible to you. So this is the basic, and that is why Pradhan Mantri Gati Shakti Yojana is also very curious to connect all their projects to remote sensing, and that is why they have granted almost 1,000 crore to BCST, and that is a government national agency of remote sensing in Gujarat, that to handle all the data. And they were on 12th and 13th we were having certain workshop related to it, where each and every department of Bihar has came and they have shown how 200 layers have been created on their site by the each and every department information is there on the BCST portal. So each and every department, for example, Panchayati Raj, RCD, PHED, WRD, everyone, if they want to see the data, Each and every department can see the data there. They cannot download it because of the obviously their safety reasons, but they can see the data. So that will help in planning. That will help in, because what happens generally, whenever a new road is made, constructed, after the road is made, again the some UDSD people or Nagar Nigam people, they will come or they will say that no, we have to dug a drain there. So again, that road will be destroyed in that process. So if they will see each and every data, so they will see, okay, now they are preparing to plan to construct a road there. So okay, first we have to complete the work based on drainage. After that, they can do their road network. So in that coordination, the government will not have any loss. So this is the very important thing, because you are having 200 layers, 200 in data information, and you can open that layer at a time, or by layers you open it and you can identify your data there, and by just clicking on the attribute table you will be able to see each and every each and everything over there. So this is very helpful. Since we are working on it, so we are seeing the live things, what is happening on remote sensing. If we have to geo-reference it also, then also we can geo, because there are locations are there, x-axis, y-axis, coordinate options is there. Just we have to put the latitude, longitude values, and you will be able to locate the control points or ground points also. So these are the things which are generally steps in remote sensing. I think those who have worked on it, they might be knowing steps, but method is same. But what are the applications in different fields? The methods will be same, but in different fields we have to extract certain features. For example, if we have to see water bodies, we will click on the option clip, and that water body area will be clipped and that will be extracted out easily. So these are the certain things, certain tools which we generally use, either ArcMap, QGIS, ERDAS or ArcGIS Pro. Generally ArcGIS Pro, ERDAS, these are the costly software. These are having higher cost. QGIS is free of cost, and ArcMap is also having certain.
Excuse me, ma'am, the slide is not changing.
Hello?
Ma'am, slide is not changing.
I'm just explaining about the step, that's it, right? Okay. Now, I think it's clear. Now, I am just telling about the applications of remote sensing in different fields. I have already discussed so many examples. It can be useful in urbanization and transportation, agriculture and forestry, natural resource management like wildlife habitats, diseases mapping, non-permeable surfaces, hydrology, infrastructure planning, weather forecasting and analysis, disaster management, and medical. Nowadays we are working, I'm again giving an example, because in slides we are not able to write each and everything. So for example, like we have to do morphometric analysis on bridge. In this project is given by our bridge construction, that is under RCD only, that we have to identify stable zones for construction of bridge. Because generally we see in the news that every time bridge is falling, so they are not having that team there. So we have to identify the stable zones over a particular area, like they were working on Kosi, because Kosi is a very dangerous river, and we all know. So that is the thing. So we have to analyze the morphostable zones over there, so that bridge can be constructed. So these are the projects which are generally coming based on remote sensing. Now this is the remote sensing application. What are the applications in Bihar, which Bihar has used? Now this is our logo, Departments of Science and Technology. This has been a remote sensing center, has been established in 1985. These are the projects which are going on. Agriculture application. for rural development. These are the land use, land cover of the, all generally for Bihar. It has been all Bihar area. It has been shown soil type. It's a slope and contour area for urban planning. This is the disaster management, flood modeling, flood inundation map. These are being drawn. These are for industry network, where the connectivity of industries of whole Bihar. Now this is for mining department. They have done for Aurangabad, sand and stone mineral surveillance, watershed monitoring under geospatial techniques. This is Pradali burning. Every day they are getting data. Every week they are giving data related to Pradali fire working thing. So these are the projects. These are some of the remote sensing sources, which we can get online resources from remote sensing. This is the final conclusion that it enables observation, analysis, and monitoring of Earth's surface, atmosphere without direct contact, utilizes satellite or airborne sensors to gather data, provides accurate, timely, and large-scale information, supports informed decision-making and sustainable resource management. Technological advancements are making remote sensing more precise and widely accessible. Its applications are expanding across scientific, commercial, and governmental sectors. Ultimately, remote sensing enhances our ability to understand and manage the planet for current and future generations. Thank you. I hope you all have understood a little bit about remote sensing and how it can be used, the different tools. I think everything is available on net. Each and every one of us knows about it. But little bit of things which I have tried to combine and I have tried to get some information, at least basic information about remote sensing, because it's a very, very important topic. So any questions or any suggestions or any information you want to add regarding remote sensing, because it's a wide thing.
Thank you, ma'am. Very informative session was there. You have explained every small points of remote sensing in a very efficient manner, so that the person who is not from directly remote sensing, he can understand the thing you have explained. Now, I request any faculty member or teacher who are there, if you have any query, please ask. Please feel free to ask or write in the chat box. Just within 5 to 10 minutes, we will conclude. So feel free to ask the questions or little bit doubt, any doubt related to it. Yeah.
Information you want to give, because it's a very knowledgeable thing. I will also get to know, because everyone can't understand each and everything. Everyone will not be able to know. So I will also be happy to know if anybody is having various other sites or etc. for downloading imagery or anything related.
Ma'am, hello?
Yes, sir.
Ma'am, can you give some suggestion to all the female faculties and girls scholars, research scholars for pursuing this remote sensing field? If they are, if they want to pursue this field, can you give some suggestions?
What are the area where they can proceed?
In remote sensing, we are having like, first of all, I will want to invite all of you to Bihar Remote Sensing Center. It's in the Taramandal, in the second floor is there. And each one of you can come here. We are having various lab facilities. We are having power stations on which we are working. We are having very efficient systems. Many softwares have been installed. So first of all, I would like to invite all of you to come and see here. There are many senior scientists, female scientists who are working. They are working from past 20 to 25 years. They have been joined with this organization. And basically for women, if I want to suggest that since nowadays each and every woman is working hard, no one wants, even a small graduate or 12th pass lady will also want to pursue or study or do job. So every researcher here who is working and teaching job is very, very noble things, not for ladies, it's for all of us. Being male or female, it's a noble job. But for ladies, since we are having other responsibilities, household responsibilities, so teaching or research field is really very, very important as well as very useful for us. In remote sensing, we can have a wide scope because it is applicable in each and every field. So since I am from civil engineering, so we are having some part of remote sensing, we can say, but we are having our geology members here who are very, very pro in remote sensing. So I am seeing that each and every one is having a wide scope. If we are seeing, like for example, I have told now PhD, they are having 54,000 maps and we have to digitize it. So it covers a large budget also. For example, each and everything, processing, everything is having certain budget on it. So large, if we will be leading larger project, then it will be our opportunity for leading such a project. Because being female, if we get opportunity, we all know that female are hardworking and also they are very, very dedicated to their work. I'm not telling that males are not. But all of us know that females are also, because they are said that super women. Why? Because they are handling various jobs. Household work also, office work also, everywhere they are there. So they are multitasking people, we can say. So if we are leading heavy amount of projects, then it's a very, we feel satisfying or we feel very relaxing that yes, we have done something. So that can be a big motivation. Every day when we see our projects, what we are doing, we feel that yes, we have done something. Obviously our academics is there, but just adding on after academics, these projects, these really enhance or improve our leadership quality, as well as also we get to connect with so many people. We can say that while doing any project, we are getting opportunity to connect with people from secretary level to lower level. Each and every one we are giving presentation, we are working on it, meetings are generally there. So each and every step which we are taking is really, really very satisfying for all of us that okay, we are working. So for women, remote sensing can be thing because we have to sit at the office.
One more question. How can we apply if you want to do some research in this remote sensing? How can we apply? What are the various sites or various methods by which we can apply?
Every time in ISRO, if you will go to the site, ISRO site, every time there is some bucket program is going on. I hope everyone has heard about this bucket program.
Can you explain?
In ISRO, we can submit proposal. Here, some of the professors, while going on the ISRO site, they have submitted their proposals on remote sensing. They always invite for proposals. In the same way, you will go on the site of BCST, Government of India. They are always inviting for proposals. Just you will go on the site and you can see there on the left hand side, when there is notices and all those things written, they are calling for invitation for papers, for you can say for these proposals. In ISRO, there is a program called Bucket Program where you can apply for it. So these are the certain sites which we are also getting aware.
And ma'am, are there some projects which are running on which we can collaborate?
Yes,
Taramandal.
one of the project which we have submitted a proposal. If that works, then obviously you all can connect like groundwater potential zones. In Bihar, nothing has been done related to groundwater. Means okay, various departments are there, water quality monitoring, everything is happening. But in hard rock areas, especially in those areas like Gaya and all, where water scarcity is there, so there we are trying to analyze the ground potential zones. We are trying to analyze it. We will be working on satellite imagery. That project is a heavy, immense project. On that you can connect groundwater potential zones. We have to find out different water levels in hard rock areas.
One more question, ma'am. One question from the participant has came that how can we control the floods in Bihar using remote sensing?
That we are also working, because remote sensing center, we are using generally Sentinel-2 images or LS4 images, that is giving 5 meter or 10 meter resolution. But when flood come, it is a certain process. So in that thing, we have to do real-time monitoring. And for real-time monitoring, we have to use sensor data of at least 0.5 meter resolution, so that flood maps can be created. Even through real-time monitoring, we will be able to give early warning to the people, to the local over there. By using high-resolution images, flood maps can be created. Not by using Sentinel or LS4, but by using 0.5 meter resolution images, we can draw map. But obviously that is very costly there. So that is, we are working on it, that we can buy those things. Proposals are made, estimates are there. So that's another process that is taken by government side. But yes, we are working on it so that real-time monitoring can be done, and we will be able to give data of hourly data. We cannot, because satellite also take time. So we will not be able to get minute to minute data, but hourly data we will be able. But the disaster management is working on it. They have connected with some private agencies, and they are doing real time monitoring. Because in disaster, they were selling that funds are there, especially for creating these real-time monitoring things. So they have bought those costly data, and they are working on it.
The participants can ask their queries in chat box also, and if they want, they can raise their hand and ask directly. If you have any queries regarding the remote sensing, its application and its works in Bihar, you can ask the questions to ma'am. One question from Souvik Chakrabarti has came. Can we model groundwater quality by remote sensing?
Yes, sir. Yes, sir. We can model it. We can model it if we will be getting data. We will be able to model it, because in remote sensing in ArcMap or in ArcGIS Pro or ESAR, we are having that option of model builder. We are having that option of model builder. So if we will click on it and we are having sufficient data or proper data, we will able to validate that model. Yes, we can do model.
And related to this, I had also one query that since Bihar is having a serious issue with acidic poisoning,
yes.
because cancer and all these
Yes,
are growing, they are growing in number in Bihar. So what can be done related to this arsenic matter?
Hotspot areas identification project has been given by again PHED and Central Groundwater Board. They are doing combined, because data are in both departments. They are also doing that thing, Central Groundwater Board, and again PHED is also doing water quality thing. So they have given us project to identify the hotspot areas. They have given us a pilot project of Barhara, and Barhara area that is in Ara, Bhojpur district. So they have given us to identify hotspot areas of arsenic, and in some of the tube wells which are having highly arsenic contaminated, and people are still drinking on it. So they are trying, because survey is very difficult in villages or remote areas. So they have given to identify hotspots. So in that we are using IW tool, reverse distance weight method. I think you might be knowing. In that tool only we are drawing spatial distribution maps, thematic maps. They are also giving some data which are with them in their JJM portal, Jal Jeevan Mission portal. They are uploading those data, so they have given that, and we are trying to identify hotspot of all they have given in Barhara. Later they will proceed to all over Bihar.
Okay, ma'am. And one question from Dr. Ravi Shankar sir. He's saying that I think the catchment mapping from 5-meter resolution or 10-meter resolution will not make any difference. And the catchment geology, basin morphology will be more effective. So I think he something related to the resolution of the mapping.
Yes, sir. He's telling it right. I agree with him. But what happens that since I'm again telling that less resolution data is more perfect. If we are getting 0.5-meter resolution data, then obviously we will be able to model anything, or we will able to extract any feature very easily. But since we are not, since 5-meter or 10-meter resolution data is very means easy to get free of cost, so we are using it. It doesn't mean that if that project requires that we should use 0.5-meter data, then we will buy it and we will work on it. So all depends on the type of project which we do, the project cost because the project cost, with the budget we are giving, our BSAC lab is having certain budget, they are having certain rate, they have their fixed rate of image processing, manpower, contingency, all those things are there, they are having their fixed. So whatever project budget we get, whatever project fund we are getting, from that fund we can obviously buy if we require. If we are seeing that catchment is not, we are not able to identify the particular catchment properly by using 5-meter 10, then we can go to higher resolution data. 2.5-meter, we have also used 2.5-meter resolution data also. So depending on the costing, we can get it.
Is the all the means whatever the data are there, they are open source, or we have to purchase some license to access them?
No, these are not open source. We have to buy. License is there. No, the data, which data? Sentinel-2 or these 4 ones you are asking?
And data to related to various kinds of maps are there. So these maps and all means, suppose if we want to do the mapping and do some research.
Maps free of cost, I think.
Yes.
If you are going on the site Survey of India, you will be able to free of cost, those maps will be there. But again, if you want to use some departmental data, for example, any flood, for example, in disaster management tools, you want some data, then obviously you have to buy that data.
Okay.
Some of the sites are free, and some of the sites obviously you have to pay for it. In the same way, images, satellite images, if you are using some of the sites like Copernicus, they are giving free images of up to 5-meter resolution.
Okay.
And some of the images you have to buy. So each and every image cost is there, since we are government body. So they are having a fixed rate there.
Any more questions from the audience, or is it over? Is there any more query from the audience? Or we can conclude this session, and at 7:30 sharp, we will be proceeding for the next session, that will be in Geographical Information System, GIS. So this session was for remote sensing, and the next session will be from GIS.
Thank you.
Okay. Okay, ma'am. Thank you, ma'am.
Okay, thank you, sir, for joining, and thank you all of you for listening so patiently. So thank you one and all. Thank you.
Thank you, ma'am. Thank you.
Thank you.